This talk is going to be about Flask and specifically Flask's flexibility. I'm a new developer with regards to Flask. I've used a lot of other web frameworks, the majority of which are frameworks that are very much focused on connecting or basically talking to a relational database model. The application that I'm going to be talking about, contextualized, is anything but a relational database model. It's a graph database. So I'll start. Okay, let me first introduce myself. My name is Brett. I'm Dutch, born in Africa, but currently living in Norway. I identify as a software developer, but I've done a lot of things, a lot of different roles. Excuse me. Sorry. I've also been a CTO for 4 years, and currently I'm doing a more marketing role. I'm very much a semantic technologies enthusiast. I've also worked using semantic technologies. I've worked in the tourism industry in Spain, and I'm now working in the edtech sector in Norway, and have been in the edtech sector for the last 8 years. Okay, there's a couple of things I would like to go through. So these are the talking points. I'm first going to explain and walk people through the topic maps paradigm. After that, I'm actually going to show the application. Then I'll come back to the presentation and we will talk more about Flask. Again, this is from a person that is quite new into Flask development. So it's a person with a newbie perspective. Then I'll be talking about the repository pattern, the actual underlying architecture. It's based on what's called the repository pattern. Then I will explain briefly how I've actually wired that repository, the data backend, the data store, how I've wired it up to the actual application itself. And then if there's time, I'll go through other Flask features that, from my point of view, have really made my life easier developing this application. First of all, I want to start with topic maps. Topic maps comes from these semantic technologies, a group of semantic technologies. Topic maps is one of them. Topic maps really are, it's a very, very powerful paradigm, and it really allows you to describe, to express complex relationships between concepts and the information resources that you need to connect to those concepts. There are three main models or domain models. The domain model, the topic map domain model itself has the three most important entities. One is the topic, the other is associations, and the third one is what they call occurrences. So a topic, like I said, a topic can basically be anything. I mean, I'm a topic, FlashCon conference now is a topic, my application is a topic. Anything that makes sense to you, you can basically consider it to be a topic. Once you've established a set of topics, obviously from that point onwards, where things become very interesting is when you start relationships between these topics. So that's what an association does. But where topic maps probably go further than the majority of other models is that the relationship that you can express between topics is semantically meaningful. So when I'm establishing a relationship, when I'm asserting a relationship between two or more topics, I can say this relationship is of type. That type is a topic. So everything is self-referential in topic maps. But also I can establish the role that the topics are playing in this relationship, within the context of a relationship. So if we look, I'll quickly put a very simple example on the table. If I'm thinking about one of the most natural relationships that we have between a son and, for example, his mother, then the type of relationship, I could say it's of type family. Family would be a topic. And I could say that the role that I play in that relationship, within the context of that relationship, is one of son. Son would also be a topic. And my mother obviously would play the role of mother, and mother would also, that role would also be a topic. Those roles are separate to the actual topics themselves. So there would also be a topic for me, there would be a topic for my mother, and there would be a topic for the family type. Occurrences are what allow you to actually connect resources to topics. Topics, for all intents and purposes, are nothing more than an identifier, something that allows you to attach something else to. So occurrences allow you to actually establish a connection between a topic and what are called information resources. And information resources can, again, be anything. An information resource can be an image, it can be a spreadsheet, it can be a PDF, it can be a link, it can be a YouTube video, it could be anything that makes sense to you within the context of that topic and what you need to provide in order to represent that topic. And occurrences allow you to establish those connections between the topic and the information resources. I won't go too much into scopes and scope filtering, but scopes is a very powerful concept within the topic map paradigms, and it really allows you to establish, let's call them points of view, perspectives. And then finally, you can also attach metadata to everything in a topic map. So I can attach metadata to a topic, an occurrence, and an association. One final thing I want to say about the actual model itself: associations, or they are used to assert the relationship between topics. Associations in themselves are also topics. Okay, I really believe in show, don't tell. So I'm going to actually switch from the presentation to the actual application itself. The application is called Contextualize. Let me see, I hope I don't have too many problems doing that. Is everyone seeing this, the Contextualize application?
Yes, we are.
Okay. Okay, I'll actually log into this application. I have two, so when I've logged into the actual application, I'm presented with my set of topic maps. So I can have multiple topic maps. Topic maps are self-contained, so they really, a topic with a topic identifier in one topic map is completely separate. It's a separate entity to the same topic, or a topic with the same identifier in another topic map. So I've got several topic maps in Contextualize. I'm working on two specifically. The one with regards to Python is a topic map in which I've set up the topics, I've set up this, the associations, and I have not actually attached any information resources to it, but I'll show you. So if I now go into this topic map, there's always the first topic that you are presented with. It's a auto-generated topic, is called the home topic. So this is always where you come back to and where you branch off from when you're in a topic map. But I want to show then the Python topic. So yeah, you can see again, this topic I have not attached any information resources to, so it's quite a bare topic, but I have established the associations. So I can obviously, like the majority of these kind of applications, I can now also see the relationships between the topics. You're always within the context of a current topic. This current topic in this case is this one, the Python programming language. And now I could also use this. This is navigable, so I can use this. I not only see the context of this specific topic, I can also use this to navigate to another topic. So I would just click on that node, and then the application has taken me to the other topic. Another thing that is quite interesting in the application is that I'm using the topic map model for things like what I call knowledge paths. So this thing at the bottom here, where it says previous, down, and next, that basically provides you with an hierarchical path through the topic map that you set up. It's using associations to do that. If I had to open up this one here, you could actually see the associations and the roles that they are playing within the context of this specific topic. Likewise, the application also uses associations to establish tags. So when I tag a topic, it's not just a simple tag. What happens under the hood is that an actual tag topic is created for the tag, and I then create an association between the topic that is being tagged and the tag topic. So if I click on that now, I can see all of the topics that have been tagged with this web tag, this topic that is, or the web tag. And then I could obviously navigate to any of the other topics that have this tag as well. I'll now go back to another topic map, because then I can show the actual information resources. Sorry. So like I said, one thing is the topics. Here you can see a topic where I've actually started adding a text occurrence to that topic. So I can attach text, I can attach notes to a topic, and then I can also start attaching resources, information resources to a topic. So I will navigate to an actual, sorry, I will, let me see. I will navigate to this one. So obviously, like I said, topics have text, topics can have notes, topics can have images, files, links, videos, whatever is relevant for you. So here you can see just images that have been attached to a topic. I can also, like I said, attach videos to a topic. And this being the modern web, I can also attach 3D, GLTF-based 3D scenes to a topic. So this is, yeah, this is 3D web. At some point, probably after the summer, there will also be support for augmented reality and virtual reality occurrences that can be attached to topics. Okay, I'll go back to Lightning. That was a Lightning walkthrough of the application. I'll go back to the actual presentation. So as I said, I've just explained that the application can have multiple topic maps, topics, associations, and occurrence, which is what allow you to connect information resources to the actual topics. Just before we started the actual presentation, we were discussing different frameworks. Obviously, when I started implementing the actual application, or before I started implementing the actual application, I had to think about what framework am I going to be using. The actual topic map engine, the underlying engine that is used, I implemented over 3 years ago. I only started developing the Flask app about a year ago. So the two things were developed quite independently. And that's important because I didn't develop the one taking the Flask framework into account. Yet with the Flask framework, it was very easy, surprisingly easy, to basically wire up my backend to the actual web application itself and use it and integrate it into the Flask framework. So to understand why, from my point of view, Flask made a lot of sense with regards to the choice of framework to implement contextualized, well, let's have a look. So obviously, again, this is a beginner's perspective. Looking at Flask, Flask is very small, so it's something that you can quite easily and quite quickly pick up. It also allows you, because it has a small footprint, to really focus on what you need to focus. Anything that it does not provide, it probably has an extension for that, or you can use the Flask facilities themselves to extend. There's a large and active community, which is always important when you are starting to build an application on top of open source frameworks. Very good documentation. I read the documentation. I went through the documentation a couple of times. And from that point onwards, I started building the app, and it was all very straightforward. And then also a very important point, Flask is unopinionated. And why was that a good thing for this application? Well, because my application, the backend, is very opinionated. So if I tried to integrate my backend with, for example, something like a Django, which is a very opinionated framework, I think I would have run into difficulties. Django gives you a lot out of the box, but it is very much relying on the fact that the backend is going to be a relational database backend. My topic map engine is not relational, it's a graph database. So with Flask, it was just very easy, and I'll come to that, it was very easy to do that integration of the backend. Okay, let me see. My backend concept, from an architectural point of view, it's what's called a repository. A repository is a specific enterprise pattern Conceptually, a repository allows you to encapsulate a set of domain models, and then also it provides a set of methods, or it provides an API to actually be able to manage those domain models. The repository pattern, like I said, it's an enterprise pattern. It mediates between the domain and the data mapping layers. Yes, it does. It's beneficial for a system with a complex data model. The topic map domain model is relatively complex. Not too much, but there is some complexity there. And then also specifically in Python terms, and this is the crux of it all. In Python terms, my topic map engine is basically a context manager. And a context manager, as people know, provides basically an end-to-end exit method. That end-to-end exit method, or those end-to-end exit methods, they obviously have open and closed semantics. And this was the crux. This was the trick that allowed me, or the thing that allowed me to very easily integrate my topic map engine with Flask. So I'll quickly go through how I did that actual wiring up and using of the data store. For a lot of people, for a lot of veterans, Flask veterans, people that have been using Flask for a long time, this will come as no surprise. For somebody that's coming new into this, it was very much a surprise. So I'm hoping there are some people that are new with regards to Flask development, and will take this point away from the presentation. The Flask documentation, like I said, I think it's very good documentation, and this is almost line by line lifted from the Flask documentation. There is a tutorial in the Flask documentation. I think it's a blog application, but at some point they're saying, well, how do you actually connect your backend how do you wire up your backend? This is how you do it. At some point, you have a get topic. In my case, a get topic store, or in the case of the actual application in the documentation, it was get DB. You then return. So you instantiate that object. You open the object, and then you return that object. From that point onwards, in your blueprints, you would be calling get topic store to actually get access to your backend. In my case, the topic store. Obviously, you also need to, it's request response based, and once the responses come to an end, it needs to also close the connection to the backend. So you also provide another method, which is the close topic store, and then you need to register that with the Flask application, so that it knows that at the end of the request response, it knows that it needs to call this method. So in my case, it's this app teardown app context closed topic store. It calls that method, and then the connection to the closed. And then at some point, you need to register all of that in the Flask app itself. Again, if I just go back to the previous slide, this is it. This was literally everything that I was required to provide in order to wire up a completely separate backend, a backend that was developed independent from the actual front end, which was developed years later. This is it. It's quite phenomenal. If you come from other frameworks, specifically in the Java world, then only having to do this, it was a mind opener for me. Okay, once you've actually wired up your backend, obviously at some point you need to be talking to that backend. So I've got an example, a piece of code here from one of my blueprints, a video blueprint. So here you can see at the beginning of the method, I actually say topic store equals get topic store. Some error checking to make sure that everything is okay. And then I say also at this point, okay, get a topic from that topic store. Again, some error checking. From that point onwards, because I now have that topic store available, and that topic store exposes a complete API for the topic maps domain, I can do whatever I need to be able to do, I can do within the Flask application. I don't know how much time I still have left, so I think I can still just go through this. There were some other things, again, as a newbie using Flask, that really did make my life easier as a developer. specifically blueprints. In other frameworks have something similar. They normally called controllers, I think, in the majority of other frameworks, but because I have several domain models that I need to be dealing with, I have a blueprint for each one. I have a blueprint for topics, I have a blueprint for for associations, a blueprint for occurrences, and blueprints allow you to just encapsulate all of that and isolate it without any problems. And obviously it allows you to extend the application seamlessly. Filters, I use filters quite a lot. I want to be able to pass in a topic identifier and actually have something quite more complex than that returned back to me. Filters allow me to do that. And then finally, extensions. There are multiple extensions. Flask security is one that I'm using for the actual application. So again, Flask is considered a micro framework, so a lot of things you have to go out and find an extension for it. But I think that works very well. I've used Flask security too for my authentication, logging in, logging out, and managing users. Obviously, Flask WTF, the forms extension. And then finally, at some point, I hadn't figured out exactly how to use WTF, Flask WTF, with regards to passing in the CSS classes to style my form. So some of my forms, old legacy forms, are still using another extension, Flask CSRF, to ensure that the CSRF aspect of things is dealt with correctly. I think that's my time, but I'm not sure. Okay, I'll put this up still.
Thank you, Brett. That was an excellent presentation. And so we are open for the question and answer session. Anyone has any question?
Yeah, I have a question. So
Yeah.
first I would say it's very nice, and especially it might not be the Flask specific part, but especially topic DB. Sounds like a very nice project, which I could also use for my project as well. So
excellent.
There was one question about topic DB. Is the Postgres integration, is this hard implemented, or is also another database backend possible?
Topic DB was initially envisaged to be database agnostic, but at some point I basically abandoned that effort. I fell in love with Postgres, and it was, from my point of view, was the database that I knew I was going to be using. So I quite quickly removed all of the code that was which would allow you to plug in whatever database system you wanted. But it is a quite straightforward thing to do. At some point, I was using what's called a strategy pattern that would allow you to just swap in or swap out different database, the actual database backend. So if somebody would want to add support for another database, it wouldn't be an entirely difficult thing to do. But currently, topic DB, so that's the actual topic map engine, the underlying data store, it's PostgreSQL only. I saw in your presentation that you were using MariaDB, so that's more MySQL. So I understand the question. Yes, yeah.
We have a question.
Yeah.
It's about someone asking, how do you define associations, and if roles are possible?
Sorry, how do you find associations?
Define.
Yes, someone asked.
Define. Okay. So, like I said, associations in the topic map model are semantically meaningful. Oh, do you want to see it in the actual application? I can actually show you how an association is created in the actual application, if that's the question.
Okay, and how do you someone asking, how do you programmatically traverse the resulting graph?
So two questions then. First of all, so when you want to create an association, you get this form. This is probably the most complex form in the whole application. Nonetheless, you only do have to provide one value, and that is the destination topic. So the ID, the identifier for the destination topic. So I mentioned that you always within the context of the current topic. So when you create an association, you're basically asserting a relationship between the current topic. In this case, the current topic is called something Codex Roboticus. I'm asserting then a relation between this topic and another topic, and that's the destination topic. So obviously here you just start typing in the topic identifier, and there's an autocomplete, and it will then just provide you with the appropriate topic identifier. Also, if you provide a topic identifier that doesn't exist, then at some it will actually say, hey, are you trying to actually connect this topic to something that doesn't exist? Do you want to actually create the topic? And it will create the topic, and then you can carry on filling in the form. Everywhere where a topic identifier, the majority of the forms at some point you need to be providing a topic identifier. Everywhere where you do, you have an autocomplete, and you have the ability to inline, in place, create a topic if it doesn't exist. But again, coming back to this, how do you define an association? So you specify the topic you want to connect to, and then you can optionally define also or provide parameters with regards to, okay, this association is of type whatever, and the roles that these topics play within the context of this association are this or this. Again, those are topics, so you'd be providing the relevant topic identifiers for that. I hope that answers how to define associations. What was the second question?
Second question was, how do you programmatically traverse the resulting graph?
Okay, so obviously recursion. So if you go to topic DB, there is a method that the topic store actually provides, get network. So you would provide a topic identifier, and from that point onwards, what it does is it first goes and gets all of the related topics for that specific topic, and then it recursively goes to the next for the set of topics that are related to that first topic, and then does the same thing. It says, get the related topics for this topic, and then get the related topics for this topic. You can specify how many levels you want to go down, because obviously if you have a very dense topic map with lots of associations between your topics, then this at some point could become a very, very expensive query. So there's a couple of things here. You can define how many levels. So I could say, I only want to go 2 levels down, or 3 levels down, or 1 level, just give me the immediate related topics. And also there's a timeout on the actual method itself, so that at some point, if after 30 seconds it hasn't returned, it will time out without actually breaking the application.
Okay.
Yeah.
I haven't myself worked anytime with Flask. I usually worked with Django. Did you try Django anytime?
I actually, when I started thinking about implementing a front end or an application for the back end is something I wrote and still am maintaining, but I wrote it probably about 3 years ago. So it's only about a year ago that I started developing the web application for this backend. And obviously I looked at Django, and Django is a fantastic framework.
Yeah.
But it is what it is. It is specifically for those kind of applications where you do have a relational database, and where you are dealing with a customer table and an inventory table and a sales table with sales item. This very relational data model. That I came quite quickly to the conclusion that this is not at all suitable for me. I need something else. And then I looked at Pyramid and I looked at Flask, and I ended up with Flask. And to this day, I think it was a very good choice. I've had no disappointments, none.
Okay, thank you, Brett.